All right, welcome everybody. We're gonna start covering some quasi experiments from here, and I kind of broke this up into a couple of areas, and I threw it all into one slide though, or one lecture. But we'll come back for part two of quasi experiments, which is more the long-term design, the repeated measures type stuff, and I'll talk a little bit about cohort analysis with this one, but keep in mind it also works for the next large group as well. So the next, like the repeated measures designs and the long-term studies. So, all right, quasi experiments. Here we go. The only thing that makes a quasi-experiment quasi is the fact that you don't have random assignment to conditions. That's all there is to it. In other words, the conditions self-select. Okay, so one particular class, let's say Joe Bob's fourth grade class, is going to be in receiving direct instruction this quarter, okay, versus somebody else. So you didn't randomly assign people to conditions. You just naturally assign those conditions based on the groups that exist. So you lose a lot of control when you do that. Okay? In other words, you inherently weaken your internal validity. Okay? One of the things random assignment really does control for a vast majority of those threats to internal validity, and it does it because you're randomly distributing those individual variables and the probability of those variables happening across both groups. When you don't do that, then you don't know that your groups are truly equal. So randomness really allows you to create, logically anyway, it allows you to create equal groups for equal, so you can make the comparisons. Right? With quasi experiments, you're not going to do that. You're not going to do that random assignment. So you're never going to be completely sure that the groups are perfectly equal. And as a result, you run into some problems in terms of the analysis and in terms of causal inference. The basic argument is that with weaker designs, you have a lower ability to detect an effect, right? So you have a lower ability to say what's really going on. Now, your statistics will still work. That's not what I'm talking about here. I'm talking about interpretation of those statistics and the fact that you may not be able to say what you want to say. So X caused Y. Well, you can't really say that with a quasi experiment, but we can do what we can. I mean, we can do what we can with what we got. So there's ways to make it better, and there's ways to control for certain components and things like that. But that said, there's some really really weak quasi experiments, and I'm going to go over a couple of those, and then we'll kind of go through all of them. All right. So let's look at how we actually start to establish this causal inference. Number one, we got three principles that we're going to work with. We're going to identify the threats to validity, and we're going to study them. Okay? So we're going to dig into them. We're going to jump into those things that would cause us problems. And we're going to do that because if we don't, then we won't know if they're present or not. If we know they're present, then we may be able to control for them. Or if we study them and we find out that they're not present, then in a sense we controlled for it. So we're going to identify them, and we're going to actually study them. Primacy of control by design. Right? In other words, we're going to start out by doing what we can to the design because we already know there's going to be threats, right? So we know there's going to be threats. So we're going to tweak that design as much as we can to control for some of those threats, even though we're not going to get random assignment, but maybe we should do proxy pretesting or maybe testing with a different group, maybe pretesting with a different group altogether. Who knows? There's all sorts of things that we can do, but the idea is that we're going to add additional components into the design. Typically, though, what we usually do when we're talking about this is adding observations. Instead of just shooting on it, making a one-shot, two-shot observation, so pretest, post-test, maybe we're going to add 10 observations, or maybe we're going to do it in a different way. Maybe we're going to just observe pretest, post-test, but we're going to observe multiple things. Right? And if all these things are related to each other and you're getting change on all of them, then at least you're showing that maybe my internal validity is a little higher than what I originally anticipated. Coherent pattern matching. Okay? In other words, complex predictions that make alternative explanation difficult. In other words, how would we, if the end result of your study is so complex that it's unlikely to have occurred through a simple process like a history effect, then you are probably ruling out a history effect, right? So we're going to work with those complex predictions, right? And say that X will happen under certain conditions of Y, and that wouldn't necessarily be the case if a history effect was happening or something like that. So again, this is about a logical analysis of those particular threats to validity. And I really, I'm bouncing around back in here because this is all really, to me, seems like part of identification and study of threats, right? So, because if you don't study the threats, you can't do any of this stuff. But these are the three principles that lead us to how we can start to say things about cause and effect with regard to our regard to our quasi experiments. As you can see, I'm still skeptical. Don't worry, you should be. Threats to validity are important. Threats to internal validity are really, 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 really important. Right? And random assignment to conditions is unbelievably important because it takes care of the vast majority of those threats to internal validity. So, for me, I like quasi-experiments. I do a lot of quasi-experiments. This has been a majority of my research has been quasi-experiments. But I do my best to take a quasi-experiment and try to turn it into something more experimental. Because I want to be able to draw some conclusions from it. I'm really skeptical when people start drawing conclusions from quasi-experiments, especially when they're talking about cause and effect, because there's some arguments as to the misuse of statistics based on what was said in this book. The Shade is actually the original book by Cook and Campbell, and I think that people have gotten away from being overly cautious with their interpretations. And so I'm very skeptical about how I interpret quasi-experiments, and I still like them. I still do them. They're very common. But I do my best to maximize that internal validity. And how do you do that? Well, you do that with, maybe you can't randomly assign individuals to conditions, but maybe you can randomly select classes to participate. So let's say you've got a school district that has 5 fourth grade classes. Well, you could randomly select 2 of those to be your experimental, and randomly select 2 of them to be your control. You're not randomly assigning kids into them, but you're at least randomly assigning the treatment to those and assuming that the classes are probably somewhat similar. And we could talk about matching and doing those things, which we'll talk about later. But so I'm still skeptical, even though we've got these 3 principles that we'd like to use to make sure that our threats to validity are controlled for, but there's a lot more to it than just that. All right, so let's start looking at some of these designs. I'm going to kind of bomb through these designs a little bit because they are in your book, and I didn't cover them all. I'm just covering the ones that I've either played around with or I think require some further description here. Right? So we're going to start out with the weakest of all quasi-experimental designs, and those are designs that have no control group. Right? In my opinion only, and your authors disagree here, that there is no causal inference. You cannot detect cause with these. Now, your authors say, well, you can detect a little bit of cause if you rule out X, Y, and Z. Nope, I'm sorry. I disagree completely. Your authors are great. I love that textbook. It's one of my favorite textbooks. But, gosh, come on, guys. Let's make sure that we say what we really mean here, and that just because we think we can control for something with statistics doesn't mean that you actually have cause and effect. Maybe I'm a little bit antiquated in my views of science. Who knows? We can make reasonable conclusions, though, and I don't have a problem with that. But let's call a spade and an ace an ace, and let's say that, let's not say it's cause and effect. Let's say we have evidence to believe that these 2 variables are strongly related, and it sure seems like variable X influences variable Y. Okay, I like that, but we're not saying variable X causes Y. So it's really cautious with that interpretation. It boils down to semantics, and I get that, but in science, we want to be as cautious and as conservative as possible. So designs with no control groups. Okay, so let's move on. Look at the ones that don't have pretests. Throughout the rest of these slide sets, X is always going to be your intervention, and O is always going to be the measurements. Right? So this thing is evil. A one group post-test only. Intervention post-test. There's no pretest. There's no nothing. There's no comparison. No causal inference. It's basically a case study. Right? But with a case study, we at least try to get some early data, pretest type data, kind of not. But my gosh, this is just not in my opinion, this isn't anything that should be going on in a laboratory. Right? If you're a scientist and you're doing designs like this, well, you're probably not much of a scientist. Right? Is there a reason for them? Sure, sometimes that's all you've got, but you're not going to draw any conclusions from it, because you can't tell where the people were before the intervention. You can't tell if another group that didn't get the intervention was changing. It just makes me crazy. I don't like these designs. All right. This one gets a little better, right? So we're going to do multiple post-tests. The intervention, O2, O3, and you got 3 different post-tests, at least in this. So we're still very weak, though. If post-test O1, O2, and O3 are all related to each other, then you would expect the scores to be kind of the same. And anyway, it's just, another one. If evidence continues to point towards a cause, blah, blah, blah. In other words, you're saying that maybe there's some evidence in here that's starting to say that maybe the intervention caused it, but how do you know? Because you didn't have a pretest or you don't have a comparison group. Anyway, let's just get past this slide. It makes me nuts. All right, here we go. Whew. Let's add some pretests. Pretest, intervention, post-test. All right, we're doing better. At least we can see if this group changed from time 1 to time 2, but we have no way of knowing if it's a history effect, a maturation effect, a testing effect, or anything like that. Can we rule it out? Not really. Not at all, as a matter of fact. We might be able to dig into it and go, well, I don't think there was a history effect, but who knows? How do you know for sure, right? But digging into it again, looking at it and trying to see if there's something there is valuable, but you're never going to rule it all out. Testing effects are definitely present here. The pretest could have caused the score in the post-test, or could have caused a change in the score in the post-test. There's all sorts of things. Maturation, people could have naturally changed from time 1 to time 2. I like that. This is where I kind of this is innovative. I kind of like this, right? One group, double pretest, post-test. Right? Not a double pretest, double post-test, double pretest, post-test. This is where we start to control for some maturation and regression towards the mean. We can get test one, let's try this again. We get time 1, time 2 at the pretest, right? And it's the same test, so measurement 1, measurement 2, right? Then we do our intervention, then we do our post-test. At least we can see if there was a trend, right? And then maybe that intervention changed that trend, or maybe that the pretest 1 and pretest 2 were stable, and the intervention then changed it to be a higher rate or a lower rate or something like that at the post-test. So we're getting there. This isn't too bad. We're starting to get into some repeated measures types designs here, and those can be very useful. And in a sense, depending on how you do this could actually be experimental, but it's never really going to be that way because it's a self-selected group. This one's a little different. One group with non-equivalent pretest and post-test. Now, this gets weird to think about. A and B tests, so test A and test B, are going to measure different things. And they're going to measure things that are as close to opposite as we can get. Right? Because A and B should not be related at pretest. And A and B should continue to not be related at post-test. If one of those scores changes in a way that it shouldn't, so let's say that your intervention is supposed to improve scores on test A. But if it also improves scores on test B, so A went up, but so did B. Oops. And probably wasn't your intervention. All right, something else was going on. At least you've got some other additional explanation that's coming into play here. So you do have all the pretest sensitization stuff. It basically has all the problems of the orange one up there. It controls for some. But it adds this additional piece of logic that allows you to tell if maybe it wasn't your intervention. So this is an interesting way to start getting at your threats to validity and saying that, okay, we're going to try and detect to see if it was a threat. But then it's the converse that makes you confident that it was your intervention that had an effect. If A did increase and B did not change, right, then you would expect that, okay, then you've got some evidence to say that you're not having a threat to validity there. But again, you've still got some other stuff going on with that one. It's not always the best. Right? But I do like it better than the other two above. So one thing to talk about, there's other stuff in here in your book, removed repeated treatments designs. Those are similar to what I'll call later on in the quarter a reversal design. So I'm not going to talk about them now. Your book talks about them as quasi-experimental. I don't believe they are. They are when you use large groups, but when you use small numbers of people, they're not quasi-experimental. They're actually have the highest levels of internal validity possible. So there's a bit of disagreement with me in your book there, and there's a reason. It's because the authors of your textbook are not small n researchers. They're large group researchers. So they're talking more about social type stuff rather than behavioral type stuff. So I'm not really going to talk about them. So I'm not really. I'm just not going to talk about them. So there'll be probably a test question or two on them, though. So definitely read up on them and see what's going on. But I will present to you some other reversal type stuff that has a great degree of internal validity. Okay, let's start to add some control groups. The dotted line in here basically just means that you have no random assignment. okay, and that your groups aren't equal. So in assignment procedure, NR, not random, okay. No pretesting, intervention only, post-test only. This prevents pretest sensitization. So now we can see, okay, well, maybe there was a difference between our groups here. The problem is, the real problem is that we technically can't compare across groups because the groups aren't equal. We do anyway, but we technically can't. So you have to be really cautious with the interpretation of this. If you have a difference between your two groups on the post-test, then you can't for sure conclude it was the intervention, because maybe the groups were different to begin with and you didn't do anything to know that. So it's an interesting sort of thing. It's a lot better than just the XO design, one group XO design, but it's still not that great. This is kind of interesting. It prevents pretest sensitization. It gives you a comparison, but you have to assume that your groups are the same. The red O basically means you have a different group of people. So you've got, let's say, 20 people for the first O, and then you get a different 20 people for the intervention and post-test. So you're assuming that those people are all the same. So think a group of kids that are all at the same level in two different classrooms. So you take one classroom and measure them, and then the intervention would happen in another classroom. Right? And then in this case, you also have a control group, so you've got another independent group of people that you're comparing to the post-test. This is a really cool design for ruling out pretest stuff, ruling out pretest sensitization and just general testing effects. But you do have that problem that you're not randomly assigning to any of these conditions, so you're never 100% sure if your two groups are equal, or let alone the additional two groups that you're using as the independent groups to pretest, the red ones, so to speak. You really don't know what's going on. You have to make some logical assumptions. You might be able to compare some things demographically and go, okay, at least all my groups have the same distribution in terms of ages. They all have the same distributions in terms of genders, socioeconomic status, all that type of stuff. So you could reasonably get some decent data out of this. I haven't seen this one used very much, and I think I'd actually like to see this one used more often. This is a pretty good design. I hammer on all designs. I pick on all these things, so this is pretty decent. I'm trying to think of an example in the literature where I've actually seen this, and I don't think I have. Cool design though. I think I'd like to see it used more often for a quasi experiment, especially if you can figure out a way to make sure that your groups are at least semi-equal. This one's very similar to the one right above, and this one I've seen quite a bit. All right, this one exists out in the literature fairly often. And instead of using independent groups at the pretest, use a proxy pretest. In other words, pretest A, test A is different than test B, but they're measuring the same construct. So think of it as an intelligence test. Intelligence test A is different than intelligence test B, but there's no way that intelligence test A is going to affect intelligence test B at post-test, because it's a different measure and it's not going to cause you to have any sort of carryover effect or anything like that. Again, my dotted lines are missing here, I apologize, but we do have the problem that we're not really sure if our two groups here, our control group and experimental group, are equal, but we can start to look at some things. Right? And one of the things that we actually like to do when we start getting these control groups is, remember I said earlier that you can't logically compare these two groups, because they're not equal, right? So you can run the statistics, but theoretically you shouldn't, because you don't know, right? So how would you analyze a design like this? With this type of design, you actually analyze it like this. You analyze A to B, right? Is there change from here to here for that group? And is there change from there to there for that group? You should expect to see different changes because of the intervention. Right? A lot of people fall into the trap of thinking they're just going to compare here. Now, a way out of that trap is to actually compare here. If these groups are not different here, then you can probably logically argue that you could compare them here. But the useful measurement, the useful statistical test here is from A to B, okay, or from time 1 to time 2. Now in this case we're using completely different stats, or completely different tests, but you get the idea. Right? If we had the same test, then we would compare there to there. So like we had on we haven't had it on the previous page. It would be basically a non-equivalent groups pretest, post-test. I don't even have it on here, but I'm sure it's in your book. So a non-equivalent group pretest, post-test would look just like this, except they would be black. So it would be not a different group or anything like that. And that's when you start to make those comparisons like that. So. But again, you're not supposed to compare these groups to each other. You can at pretest to see if they're different. And that's kind of a useful sort of thing. Well, what are some ways that we can make this stuff better? Number 1, match your groups. Right? Typical relevant matching variables: socioeconomic status, gender, ethnicity, age, and education. that accounts for so many individual differences. It's not even funny. Right? A vast majority of personality is made up from those things. Okay, so SES is going to give you access to resources. Access to resources gives you access to better education, better experience, or different experiences, so on and so forth. You get the idea. Gender, ethnicity, age, education, all of those things, when you add them together, really talk about who you are as a person. So when we match our groups, what we're going to do is we're going to find somebody, if we match on one thing, let's say age, we're going to find an age and gender. It makes it easier for me to talk about. So if we're going to do that, we're going to find one person in our control group that is 9 years old and male. Then we're going to find another person in our experimental group that's 9 years old and male. Good, we found a match. And then we go through and do that. So a 9-year-old female match, so on and so forth. Then we can add ethnicity in that. So 9-year-old female Caucasian. So we look for a 9-year-old female Caucasian in the other group, and we match those up and we make those comparisons like that. That way we know our groups are equal along these things: SES, gender, ethnicity, age, and education. What we tend to do, though, is do this after the fact. This is kind of a post hoc analysis. I'm not sure if that's the best way to do it, but that's very realistic. A lot of times when you get to the data set, after you're done, you're going, ooh, I could match this and make sure my comparisons make more sense. What it does is it tries to equate your groups. And it does. It tends to equate your groups in a better level. It's not a panacea, though, and there's a lot of other stuff you can do with matching, and I'm not really going to go into it. So you can read about it. Your book presents it really well. There's tons of different stuff you can do with this. In fact, you can use a matching variable as an independent variable and all sorts of things. But just keep in mind it's a way to make sure that your groups are more equal. Because remember, they're not randomly assigned, so we got to try and find out how they're equal as possible. However, it does create a sampling bias, because you're purposefully picking people like this, and with a certain socioeconomic status, certain ethnicity. And what happens if you find somebody that is Pacific Islander in one group and you don't have anybody in the other group to match them on? You throw them out. Well, that creates a sampling bias. Okay, we can combine control groups and pretests. Again, we're going to think about careful selection, right? But we could use matching even, that type of thing, but it's still not random. And I definitely am not going to cover all of these things. There's a whole bunch of them. So this is what I was talking about just a minute ago, the non-equivalent groups designs. All right. And yeah, again, dig through it and see how many. I think there's like 6 or 7 different ones of these. And they're all based on the same logic. So we've got similar group. We're assuming that our two groups are similar. We're going to pre-test them on one variable and post-test them on the same variable. And again, in order to make sure that you can compare these things, you at post-test to compare those groups, you do the pre-test analysis. You compare them here. If they are not significantly different, then you're probably okay to go ahead and compare here. But again, the informative variable is the change from time 1 to time 2, change from time 1 to time 2. If this group doesn't change and this group does, or vice versa, then you probably can reasonably conclude that your independent variable had an effect. Not 100% though. Notice what I said, probably, reasonably conclude, so really qualifying this stuff here. So all those previous procedures that we talked about, using pretest proxies and non-equivalent pretests and all those types of things, and other groups and stuff, can be added in here to help control for stuff. And that's essentially what all the other designs are all those additional procedures kind of put into one. All right, last one we're going to talk about is cohort designs. These are kind of cool. They're really hard to display in terms of PowerPoint. At least the way I'm trying to present them here. But so assume we got cohort 1. So let's assume you guys are cohort 1. I can pretest you guys, and in next year with cohort 2, I can do an intervention and a post-test. Because cohorts that are next to each other should be very similar. So functionally, I've got a pretest post-test measurement here, and any change from pretest to post-test might be due to the intervention. Of course, because we don't have enough comparisons in here, this is going to open up the door for maturation effects and history effects and all those things. And they're definitely not the same groups of people, but you're similar. So the cohort of people going through school psych cert, you're going to be similar to the group that's going through next year. That's just the nature of this types of things. So cohort design gets really cool in the sense that you can do some really long-term studies. And I'll probably talk a little bit more about repeated measures cohort design in the future, where you can start to track kids for years and years and years and years, and then start to compare adjacent cohorts to each other with or without interventions, and you can get some really cool data out of that. So let's look at a different one that's a little bit better. We're going to just add some pretests. Cohort 1, we're going to pretest you time 1, time 2, and then cohort 2, we're going to test you. We're going to test them at the same time, maybe, or maybe not. You know, we're going to test them again. We're going to do it as a pretest, so it's test 3. It's hard to represent graphically. If it's possible, okay, I would like this. Let's think of it in terms of years. Pretest 1 for cohort 1 is fall or summer of 2012. Pretest 2 for cohort 1 is summer of 2013. At the same time, I could pretest cohort 2 at the summer of 2013 and then do an intervention and a post-test. Right? So we're going to capture maturation variables really nicely here, but definitely opens us up to testing effects. It's entirely possible that just the fact that you took that test before will influence your scores on it in the future. Right? To make this even better, I would just go ahead and continue to keep assessing that cohort 1 and continue to assess cohort 2. So grab a post-test there for cohort 1 so you can get a comparison maybe at time 4. That'll at least start to capture that maturation variable even a little bit more, and you can start to see if it's occurring or not occurring. And you would want to interrupt that with the intervention. You interrupt that maturation variable. So again, there's a lot more designs out there like this. The last part of your chapter goes through kind of these different procedures that we use to improve these designs and tweak these designs, and it's the stuff that I've already talked about using additional pretests, about using non-equivalent pretests, about using proxy pretests, about using different groups of people, non-equivalent groups, but making sure they're as equal as possible, that type of thing. It goes through all those different procedures. So we've already covered them, really. So it's just kind of a summary of here's the ways in which we can tweak our designs to try and make them better. So we'll come back and talk more about this stuff later. Enjoy.